All right. Hi, everyone. My name is Nicholas. We'll get started. We'll get started now since it's time to start. So today we're going to be talking about Slack's vulnerability aggregator and essentially how we build a platform to manage the scale of vulnerabilities that we see at Slack. My name is Nicholas.
Myself, Atul Gaikwad.
And we're super excited to present today. So. Just to start with a little bit of an overview of what we plan to talk about. First, we're going to cover the challenges of managing vulnerabilities at scale and talk about how that led into some solution criteria for us, some requirements, some market investigation, and seeing what are the existing products that are out there and how this led us to develop our own solution at Slack. We'll go over the data model and some core features of our aggregator, and then show a short demo at the end with a conclusion and an opportunity for Q&A. So I'm Nicholas. I started at Slack about 2 years ago after graduating from the University of Virginia. I love software engineering, and particularly my role on the product security tooling team is around building a lot of automation in the security space. I also love cooking and playing the guitar.
And myself, once again, Atul Gaikwad. I'm part of the same product security tooling team as Nicholas. Before Slack, I worked for companies like Box, GE, and I started my career as a pen tester. But then over the period of times, I realized that making things are a lot more fun than breaking, so I switched my career. In my free time, I love to travel, I love to go for hiking, I love to play cricket on the weekends. This is the picture from our last offsite, which was just happened last week, where we went to Mount Rainier for the hiking. And I am local to Bay Area. I live with my family, 2 kids, so you can imagine my day-to-day life. All right. So before we get into the heart of the matter, let me tell you a story about life of a vulnerability. Now, imagine any vulnerability management space as like a kingdom that you want to protect. And in this kingdom, you have unwanted guests in the form of a vulnerability that might be sneaking onto some of the important assets for your kingdom. Now, this vulnerability could be coming in from security bug, it could be misconfiguration, it could be outdated package, and whatnot. And then in our kingdom, there is this vigilant guard, our hero, the security scanning tool, which works tirelessly to scan all these assets and trying to find out these vulnerabilities. And whenever it sees something, it would raise a red flag, and we call it as a finding. Now, this particular hero is also a good record keeper, so it doesn't keep the vulnerabilities to itself. It stores the vulnerabilities in its own database, and then from there we can share it with our developers, or it can even send out the notifications through different notification channels. Now, this hero might be good at heart, but it has its own drawbacks. So the drawbacks in the sense that it cannot discern real threats from the shadows. And if that's the case, then we need some additional help in the form of human intelligence, which normally comes from a security triage person. So this security triage person would then find out which one are false positives, which one are dragons, and which one are just lizards in terms of the prioritization. And then they might have to also find the owners who are responsible for fixing those issues. Once that is done, then it's time to call the troops, our code developers, who are the real people who are going to fix the issues. And we send out this communication through some message saying that, slay the bug, save the kingdom. While our developers are busy in doing their own magic, we want to give bird's eye view to our royals or the higher-ups, so that they're aware about what's going on in the battlefield. So we want to tell them how many vulnerabilities are out there, how many are getting fixed, what's the SLA metrics, and whatnot. And then our kingdom also has historians. We call them compliance engineers or auditors. And they would be interested in knowing which battles are we winning, which battles we are losing, and what's the gap in our defense mechanism. Now, this all looks simple if there is just one vulnerability or one asset to protect. But oftentimes, the reality is different. So we might want to protect a lot of different things. Next slide. Now let's say if our kingdom is ever expanding and it has tens of thousands of villages that we want to protect, which are nothing but the assets. It has ancient libraries with the wealth of knowledge, what we call GitHub repositories, and then 50 plus different engineering teams of the craftsmen, which have their own traditions and methods of doing things. And the very last thing that we want to do is to bother them with some false positive finding or some duplicate finding, or the finding which is not triage in terms of the priority and severity. And last but not the least, we have the watchtowers in our kingdom. We call them security scanning tools. The problem here is that as we start erecting more and more watchtowers, there would be more ravens coming in with a lot of different messages, and we want to segregate the real messages or the true positive issues from the false positive ones. All right. So after this kingdom analogy, now let's come back to the technical world and see what are the real challenges that we face in this complex world of vulnerability management. So the very first challenge is we might be dealing with like multiple different findings and assets. So let's take an example. Let's say we have 2 assets to protect. One asset has 3 findings, the other asset has 5 findings. And if we don't do anything about the scanner would end up creating total 8 different tickets, 3 from asset 1 and 5 from the other one. And this is not something that developers would be happy about. They want to have less data, but the meaningful data. And this is where we want to start grouping the findings. And the grouping can be done in multiple different ways, depending upon which tool you're scanning, what type of finding it is. It differs. So we could do a grouping based on the asset. We could do grouping based on the severity. We could do grouping based on just a package name, for example. And there could be a combination of multiple of these factors as well. In this case, we are just grouping by the assets. So if you go by the assets, instead of 8 tickets, now we are only talking about 2 tickets, which are more actionable and easy to deal with for the developer. The other challenge is the duplication of the findings and not having an automated way of closing these findings. So imagine on day 1, we got CVE1 found, and then we created a ticket for that. On day 2, if we didn't do anything different, then scanner would find the same CVE and report it back again, creating 2 tickets. On day 3, now let's imagine if CVE1 is remediated, but CVE2 is also found. So we might end up creating another ticket for CVE2, which makes sense. So, but in all, we'll have 3 tickets in our system. Ideally, it should look like this. On day 2, we shouldn't be creating any ticket, because we already have the ticket created for the same problem. On day 3, when we find that CVE1 was already remediated, we should have auto-closed that ticket without having developer to worry about log into Jira or any bug tracking system and then closing it. And then for CVE2, obviously, there has to be another ticket created. Then there is a third challenge, which is all the scanners would have some data store where they can keep the findings. And as there are like many data stores, our findings would be spread across multiple different data stores. And in order to get the meaningful data to present to our higher-ups or to our auditors, we would have to get the data from multiple different places, combine them, join them, do some triaging before we present them. All of those could have been solved if we have just one single centralized data store, which will act like a source of truth. And from that particular source of truth, it would be much easier for our higher-ups to fetch the results without having to rely on security engineers or developers. All right, so let's now talk about Slack's old process of doing vulnerability management, and I'm sure this is not going to be much different than most of the organizations do now or have been doing since a lot of time. So what you see on the screen is basically the scanners. At Slack, we have 15 plus different scanners, and they perform dynamic code analysis, static code analysis, third-party package scanning, container scanning, infra scanning. I can go on and on. Some of these scanners have the automated processing in place in terms of like parsing the results, and then opening the Jira ticket, sending out the Slack notification, uploading the findings to data warehouse and whatnot. But then there are certain scanners, or there are certain vulnerability sources like bug bounty or the third-party pen test reports, which needs to be manually triaged. And the onus comes to the triage person to do all of the tasks which are listed here, like the false positive evaluation, determine the ownership, cut the Jira ticket, find the right severity and whatnot. Now, as you might have imagined, it comes with its own challenges. All of these scanners are kind of like siloed in terms of like the way how they find the findings, the way how they open the Jira tickets, send out the notification, and things like that. And a lot of this logic is kind of a duplicate across all the scanners, and it's spread across multiple different code bases. And it would be much difficult for us to maintain if we want to make changes in any of those logics. Also, it would be a much more manual toil for security engineers in order to do the false positive triage, ownership identification, and all the things that I talked before. There is another problem, like we don't have a good mechanism in terms of deduplication or auto-closing of the findings, and because of which, like developers, even if they fix the finding, they don't have any good way to confirm if the finding is really fixed or not. So they are at the mercy of our security engineers to confirm that. All right. Now, let's quickly go through what are the good qualities or what are the criteria that we're looking at from an ideal solution standpoint. So our ideal solution should be a single source of truth, as I mentioned. It should accurately track the vulnerabilities and state of those vulnerabilities without any duplication and have the ability to auto-close the findings. It should support the automation, obviously, in terms of the grouping of the findings, finding the ownership by looking up in our internal catalog services where we keep the mapping between infrastructure services and the owners, and then come up with the environment-based scoring system so that we can adjust the score according to our environment. We want our solution to be extensible in terms of having the ability to onboard new tools, but at the same time, it has to be flexible enough to support the new data model. It should be accessible in terms of data to be queryable easy enough for our higher-ups to deal with the solution. And with that, the very obvious question that comes in our mind, isn't there a commercial or open source solution available that does all of this? And the answer is not really. When we started market research to find out if there is such solution available, we searched for about 15, 16 different solutions, and we did detailed proof of concept for 3 solutions. And unfortunately, none of those could meet all our criteria. So let me walk you through some of the deal breakers, what we observed. So first thing is lack of FedRAMP High certification. None of our vendors that we talked to were FedRAMP High compliant. They were not even moderate. And some of the vendors were hosting their solution on the cloud, on their premise. So if we have to onboard them, we would have to add them in our environment, which is adding more cost to us. So there was no real point in going ahead with those kind of vendors. As I mentioned, we had a lot of different scanners. So we have 15 plus scanners. So we were looking for a vendor that could have the connectors or have the ability to write the connectors for some of our in-house or third-party vendors that we have for the scanning our systems. The third drawback was missing critical features. So we wanted a solution that is flexible enough to help us write the customizable Jira template. The vendors that we tried with, they were able to fill in few fields in the Jira like title and description, but they were not customizable enough for us to give us actionable inputs for our developers. And even the Slack message that they were sending were kind of like a trivial in nature. So that's the reason why we didn't decide to go ahead with those kind of vendors. The fourth drawback was vendor lock-in risk. All these vendors that we talked to, they were early startups, and they were at the verge of getting acquired by some company. So there were very good chances of not receiving the same level of support that we would get when they are just startups. And last but not the least, they were a lot buggy. And during the POC, we ended up being beta users of their products. So it made total sense for us to come up with some solution which is totally in-house. We have the ability to customize it according to our needs. So with that, I'm going to hand it over to Nicholas to walk us through how we come up with such solution, and then he would also walk you through the architecture and show us the demo.
Cool. So as Atul mentioned, that leads us into our own solution, our vulnerability aggregator. But first, I wanted to take a brief pause here. I know that was like a lot of content to cover, and I don't want to just be talking at you constantly, so feel free to take a deep breath, take a sip of water, stay hydrated before I dive into the solution here. Yeah, there you go. Yeah, stretch it out. Yeah. All right. Cool, so now I'll get into it. So this was the old process as a tool covered earlier. I just wanted to show this again to show where our aggregator fits in here. So as you might have guessed, it's right in between our scanners and reporting. So there's a few new components on this slide. First, the aggregator. So the whole vision and concept here is that it's going to take care of all the deduplication, auto-closing, those redundant processes that Atul mentioned earlier. And it's also going to be able to assign ownership to the vulnerabilities, as well as adjust severity depending on the context of the vulnerability as well, and support manual flows. Now, there are a few other components here, the ownership lookup component. So all you need to know for this is that at Slack, we have an internal service called Omni. This lets us ask, hey, given a service, which team owns it? So from the aggregator perspective, it's just an API call. And then our notification service lets us easily create tickets in Jira, send notifications in Slack, et cetera. So our aggregator can be like, hey, these are some vulnerabilities. Could you please create a nice ticket for our engineers? And then the idea with the connectors here is that we're able to onboard new tools by just writing a little bit of code that's able to transform data from maybe the tool-specific format to a format that our aggregator can understand. So let's dive a little bit more into the aggregator itself. So at the core, the aggregator is just a Python service, and we're using the Fast API framework here, and we're storing it in a Postgres database. Nothing really super special going on here. The whole idea is that the scanners are going to push to the aggregator. We're going to store in the database and then expose some GraphQL endpoints that our metrics can pull from, and we'll also be able to create those notifications from. So the real kind of heart of our aggregator is how do we set up the data model? And the whole kind of predicament here is we want to be able to build a data model that's both uniform enough to represent vulnerabilities in a way that both our compliance and leadership engineers and our engineers can understand, but also be flexible enough to support different scanners and different types of scanners, whether that's third-party or even our internally built tools. So that brings us to kind of 4 core data models that I want to talk about today, and that's the first one is a finding rule. So this we define as just what is the vulnerability. This could be a CVE or like an S3 bucket misconfiguration, just what's the problem here. And then the finding is the instance of the vulnerability. So this is very similar, but now this is an instance, so it takes into account when was this discovered? Maybe is there environment information that we need to capture here that will then determine like the severity. For example, your prod versus dev asset might have different severities associated with it. And then our asset, so this is just, is it a Docker image, is it a repo, is it a host? And then a finding group is how we kind of tie these findings together to create a better experience for our engineers. So we don't want to, as Atul mentioned, we don't want to spam our engineers with findings. Instead, we want to group them together based on remediation or other criteria. So I'll just go through kind of what some example fields look like on these models, just to hammer the idea home. So for finding rule, you could have something like, what's the name? What is the generic recommendation you might have here in a reference? So this could be like to the NIST database. And then this could also be specific to the tool, like a Nessus plugin ID. And then for finding, we have fields like a description, a severity, maybe a due date, and then when it was discovered. So this contains a little bit more, adds a little bit more color to the specific instance of what happened. And then for an asset, we have something like a name, a type of asset, a URL, which might point to like what is the GitHub URL, And then here you can see we have Omni Service and Omni Team. Again, this is just ownership-related information. What's the idea of the service that's affected and the team that owns this service? And then lastly, we have a finding group, which again, is just mainly serves as a model to tie our findings together and then assign it to the proper team. So now I'm going to walk through kind of putting this together and what this might look like from going from a JIRA ticket to how we represent this in our data model. So on the left here, we have an example JIRA ticket, and it just says, hey, there's a problem with this asset, and here's a list of issues. So in this case, we represent the asset 1 is our asset, and each row here will be a specific finding. So we could also add when it was discovered to this row. And then we have our CVEs. So these are our finding rules, and again, all of these together make up our finding group. So another really important aspect of our aggregator is, well, how do we determine which findings should be grouped together? Because this can vary depending on the tool. One tool might want to group by the asset name or a specific repository or Docker image name. So how do we support that? And again, the motivation here is we want to create separate tickets for our engineers. So this introduces 2 new concepts. One is a grouping rule. So this is just saying, how does this tool want to group findings together? And then it's comprised of several grouping factors. So remember those tables I showed you earlier? Any of those fields are set as groupable fields. So what does this mean? So this means we can group by asset, who owns the assets, so the Omni team. We can group findings by severity, and we can also group by finding rule name, et cetera. Another thing that I didn't mention earlier was that we added tables to support custom fields to any of these data models. So let's say you're onboarding a new tool and you want to add another field that's not here to your finding. We support custom fields. So in this table, there's a tool called Wiz, but it could be any tool here. And it has a custom field called Wiz environment that it wants to add to an asset. Well, now for our grouping factors, we're able to take this into consideration whenever we try to group our findings together. And on the left here, this is just the field name. And then on the right, we have a priority. And how this works is that we'll first attempt to group by everything with a priority of 0 first. And if we're unable to do that, for example, we're missing a field or the data is just bad, then we'll attempt to group we'll have a fallback, so we'll group on the next level of priority. So this makes our grouping system a little bit more robust and flexible to accommodate other tools. So I'll just walk through an example of what this may look like. Let's assume we're grouping by severity and the asset name. And on the left here, this is kind of what our existing data looks like. And then on the right, this is incoming new data that's coming into our aggregator. So we have a new CVE with 2 new findings. One is related to asset 1 and the other is related to asset 2. What this looks like is once our aggregator processes it, we see that a finding 4 is attached to an existing finding group, in this case finding group 1. And then finding 5, we create a new finding group for this since it has a different severity and asset name. And also notice in this example that even though they're related to the same CVE, we have two instances of findings here with different severities, again incorporating that contextual information. And what this looks like is once our aggregator processes it, the information gets updated in JIRA so that our tickets can have the most up-to-date findings on them. And in this example here, where we're closing certain findings, we'll actually mark these findings as resolved in the JIRA ticket. So our engineers will have the most up-to-date information, and ideally they'll never have to close the tickets on their own. Instead, they can focus on remediating the vulnerability, and then once that gets updated in our aggregator, we'll close out these findings, close out the finding groups, and close out these tickets. And that brings me to the demo. So now I'll just walk through a couple more use cases and also show what that looks like on our end. So Just to start with a simple case, let's assume that we're just getting one finding and one asset in. What does this look like? So again, we're using GraphQL, but implementation isn't what I want to focus on here. But the idea is that this is what the kind of what the format looks like. This is what the scaffolding for the request looks like. And then each $sign you see here is just a variable that we'll insert our payload into. So in this payload, there's a lot of stuff here. The main things I want to focus on is that there's one asset. You can see it has a name of fake asset 1. And then there's one finding. This is a vulnerability finding 1, and then you can see it has a CVE here. So this is an example of what a tool might push. In this case, it's called twistlock, but it can be anything. It might push to our aggregator. And then we create, in our database, we can create rows for each of these data models. And here I'm just showing that, hey, we're pulling out some fields here. In this case, the asset, description, and recommendation. So once we get this in our database, we then reach out to our notification service and say, hey, can you please create a ticket? This is the information that I have for this finding group. And then I'll go ahead and create the ticket for saying, like, what's the reporter, what's the asset that's affected, and this is the finding. So let's go through another case where we have 2 findings and 2 finding rules. This looks very similar. The payload on the right, you can see there's one asset. And in this time, there are 2 findings. So in this case, one is CVE 177620, and then the other one is 21. And in this case, you can see, again, there's one ticket created, and each finding is represented as a row in its table. And also, we're using subtasks. If you're not familiar with Jira, that's totally fine. Just know that this is another way to track these vulnerabilities separately. Our engineers never really have to dig into this, but it's more a way just to track it at a more granular level. And then lastly, I'll walk through kind of what auto-closing might look like. So for this one, assume in the first scenario, like we have one finding on a ticket, and then on day 2, another finding pops up. Well, instead of creating a new ticket for that, we'll actually append to the already open ticket and then create a new subtask. Now let's assume that both of these findings get remediated on the following day. We'll go ahead and update that and say, hey, these 2 findings have been remediated, and we'll actually automatically close out the ticket for our engineers. So finally, that leads us to the conclusion. Some key takeaways here. We covered the challenges of kind of managing vulnerabilities on such a large scale. And hopefully we covered some advantages of building your own aggregation platform, and maybe even some disadvantages. You may or may not want to do this. And lastly, we covered some of the core features of what we think make our aggregator successful and something you might want to implement yourself or at least consider. And thank you all for your time. That was a lot of content. Thanks for taking the time to sit here and listen to us chat at you for a little bit. So yeah, we really appreciate it. And we're open for questions now. So.
Yeah, I have a question. So I don't know whether you have SLAs for different severity types. When you're appending issues to an existing ticket, how do you track the SLAs for remediation?
Yeah, so when we do that, like adding a ticket to the existing one, each individual subtask or the child ticket would have its own SLA. So we are still granular enough to track each individual ticket by that way. Yeah.
Another thing to note there is we also because of our flexible grouping mechanism, we actually can group by severity. So in that way, we can also just avoid having a ticket with different severities altogether.
Yeah, mostly yes, but sometimes we also take into account the environmental factors. So we consider factors like whether the vulnerability is exploitable or not, whether it has a proof of concept, whether the vulnerable code is even reachable or not, and then tone it down depending on the type of the vulnerability.
So you change it after, or like how do you see?
Yeah, so that is a feature that we are currently working on to come up with that kind of an automation that would take into account multiple different metadata. These are the metadata given by the scanner sometimes, so we can make use of those and then come up with our own way of deciding the severity. Good question.
So have you grouped the findings from different tools, like findings from SCA tool and infrastructure scanning tools?
Yeah. So again, like grouping factors would be different for each tool. So for example, if you are talking about the package scanner, third-party package scanner, you might want to just group by the package name itself, because all the CVs listed under that package would have just one solution, which is to upgrade to whatever the latest version is, right? So it doesn't make sense to have creating the tickets by the CVs. Instead, you just group them for the packages. Oh, sorry, I wasn't finished, sorry, 1 minute. If you're talking about the code level bugs, like for example, if you find excesses in one of your code base, and if there are like multiple instances, then you want to group it by just the vulnerability category for the code level findings.
Yeah, and that was part of the motivation for supporting custom fields as well, because we know each tool can have its own kind of quirks that it may want to group by. So that's why we added custom fields to accommodate that.
Yeah, you were saying something.
You guys earlier mentioned like 10 plus security tools you were trying to
Yes.
put together. What type of tools were you trying to?
Oh, so they range from static code analysis, dynamic code analysis, container scanning, infra scanning. We are AWS, so we have a bunch of tools for that. Certificate scanning, license scanning, I can keep going on. Maybe I might be forgetting a couple more.
Gotcha, thank you.
Yes.
So sometimes different types of scanners come up with the same vulnerability, and then they rate it differently. One is a high for something, one is a medium for something. And then how do you correlate that, and what is the one that you choose to show it to?
Yeah.
Yeah.
You want to go?
Yeah, so we're currently like working on deduplication, like between having different tools, like let's say they report the same thing. And that's part of the reason like we're recording so much data and like our finding and stuff, so we can pull out certain fields and say, hey, this is actually like the same issue, so we shouldn't be creating like duplicates for it. Is there anything you want to add?
So if there are like two different tools finding the same CV value, then we can look up by that particular CVE, and then we can give the preference to one of the tools over the other. So let's say if tool that we are most comfortable with, having good result in the past, we might prefer CV coming from that tool over the other one. And that's the strategy that we have used for some of our tools already. But we haven't yet come across or haven't yet onboarded tools where there would be like more frequent clashes in terms of the CVs yet.
And you have good grouping with respect to container ownership, right? I mean, that is another.
Yes.
Yeah.
Go ahead.
So, like, why are you using two different tools on the same asset?
So they don't necessarily do the same type of work. So you might have a container scanning, which will find the CV in package. And you might have tools like Sneak, or I don't want to name any vendor, but it could be anything else, finding the CVs in the packages inside your container. So there might be clashes there because they are kind of like coming from the different angles, but there is some overlap there.
So it might be like mostly in open source package.
Yeah.
When did you guys roll this out?
So we are in the process of, let me take a step back. So we started working on this project like 2-3 quarters back, and we have onboarded 3-4 tools right now, and we have more to onboard. So this would take like a year or so, depending on like the resource bandwidth and all that.
So based off of where you guys started and where you're going, did you make any changes where you realized initially, crap, we thought we wanted to do X, but we can't do that, we have to do Y?
Yeah, I'd say there's been, it's also like we have to work within the constraints of the business too, right? Like there's a lot of pressure to like, hey, we really need support for this one tool to start automating everything, because it's just like too much work to manually do it. So we definitely had to like evaluate like what are the core things that we want to integrate, and that's why why I covered like the grouping and the custom fields. Like that was really important in order to be adaptable to the different scanners. So there were a lot of decisions I'd say we like had to make along the way, and like trade-offs as well.
Knowing what you know now, would you have outsourced to use a different tool, or would you guys continue down the path you're on?
I would say no, definitely. Because dealing with the vendors could have been much more challenging than creating. This is like, we do it one time and then it's pretty much done. So initial challenge was like setting up the architecture, designs, and all that. But once that is done, onboarding the tool is quite easy. Yeah, once we have the laid out things. Yes.
Do you manage exceptions?
Fine. Okay. Just quick time check. Okay.
Do you manage exceptions state as well? And if
Excellent question. So that is also a feature that we are looking forward to. Right now, the exception process is kind of handled through one of our Slack channels, and we want to like retain that in the same one source of truth. So, yeah, that's the same thing that we have thought already about.
I think someone over here.
How do you,
Oh.
I have a question.
Oh yeah. Sorry. Go ahead.
Do you have a view of the management suite? And does the developer need to have access to it?
Yeah. So right now we don't have UI interface as such, but the goal is to give that UI interface to our developers, to our management. And imagine a developer coming into our tool or a manager coming into our tool and then finding all the issues impacting their particular domain or the team that they're. Yeah, exactly. So we have everything in that mind, and we are still in the journey. It will probably take a year or two to reach the destination.
Do you guys do triage before it gets pushed into notifications and Jira tickets, or do you have a situation where SAST runs in?
I mean, outside this tool, the overall process is like it depends.
Within the tool, like have you built any triaging, or where in this process does your triage?
So the tools that we have prioritized in terms of the onboarding are the ones where we have the high confidence. Yeah, less number of false positive based on our experience. For the tools where there are going to be more false positives, we have to come up with cleanup work at that particular tool level. And once we say, okay, we can take 10% false positive, we'll start onboarding with that expectation.
My question is very specific to container security. How do you handle the grouping when there are multiple images of the same container?
Yeah, you want to go ahead? Container security.
So when there are multiple images of the same container, we can group by like the container name and also who owns. So like one of the teams at Slack, they have like a lot of images, but it's like the same container name, or they tag it with a certain thing. So in what that looks like in our aggregator is a custom field that we're able to say, hey, please group by this field. And then that everything, all the images for that container will be grouped together and they're under the same ticket.
Yeah, yes.
So your system sounds like you're optimizing for deduping duplicate findings. We took a different route, which is we built aggregation based on what actions the end team can take. For example, our operations team owns like all of our Kubernetes cluster hosts, right? And so we scan all the hosts for vulnerabilities, but our ticket says, hey, just roll the nodes, right? They're not going to log in. Like our team doesn't SSH or log into any of our hosts, right? And so it doesn't make any sense for us to say, look, there's a CVE for this particular package on this particular host. It doesn't seem to make sense for us to even give them a ticket like that. Instead, we just say, hey, this AMI has collected enough risk. Just go roll the node. Those are the tickets that we send over. We don't actually go through this route of deduping and then handing tickets to the teams that way. We actually collectively assign risk in aggregate to a particular block of hosts, right? And for us, we went with how do our teams work versus how do we not inundate them with a lot of tickets?
Yeah, for sure.
Good.
So if we have a situation like that, I think like it's important to make a distinction between the data maybe we choose to store in the aggregator versus the presentation layer of like what we're showing to our engineers. So even though we may record that information, our system is flexible enough to say, hey, we don't need to throw all of that into a ticket. That's like, hundreds of thousands of like hosts or something like that. Instead, we can say like, hey, we know that these are an issue based on this like common factor, and then just say, hey, please, like in the ticket, we're just going to show, this is the specific thing that needs to be fixed, right?
So
that's pretty much.
To speak to the containers, we do the same thing to the various teams that own specific containers. We assign all of the risk for that one container, and then there's one ticket that says, here's all the risks that we find currently in the current state of that Docker file. Go update the file. Because that's all they're going to do.
Yeah.
They're not going to go in and individually
Yes.
update like each and every package. They're going to, in aggregate, update the whole container. A lot easier for everyone involved, especially for us. The only caveat is that for really strict like security frameworks like FedRAMP, you can't get away with that, right? You actually have to track each and every issue. We're lucky enough that we don't have to do that. And so we actually define in our security policy, in our vulnerability management policy, we actually say we do things in aggregate. We think it's risk acceptable, and auditors will accept that. The only catch is that we do monitor all of the blocks of work for criticals, because those are the only things that you actually have to move on very, very quickly. And so we'll do a triage there. If there's something that we have to do, then we'll send a ticket early and say, hey, look, it's a critical, we didn't act on it fast. Let's just turn things over faster. But otherwise, it's on a regular cadence. So interesting. Thanks for sharing.
Yeah, of course, and thanks for sharing that as well. I think like the distinction there of like how much information you want to actually show your engineers versus like the nitty-gritty details. Like we do try to record in our database like a lot of information, and that's because compliance kind of needs to know the nitty-gritty of exactly like which hosts are affected. But when we go to show our engineers this, of course, we don't want to like spam them with like all of these or everything. They just care about what is the remediation here? What do I need to do? Cool. Are we at time?
Cool. Any other question? We can take one more.
So where are we getting these findings into this tool? Is it from pipeline or is it from the tools, scheduled scans or something?
It could be from multiple different sources. So we perform the daily scan, but then we also have the pipeline scan. So we make sure that each PR gets scanned. So yeah, it depends. There are a lot of different sources.
Where are you using it? From pipeline, like you are using it from all the sources?
Oh, where the scanners are deployed in?
No. From where you are getting these findings, like in your current situation, current system, like they getting from your pipelines or?
These scanners have their own database, and we have written a parser that would pull in the findings from the scanner database, and then scanner database would get populated from pipeline or daily scan or whatever, not. So the parser is something that would push the findings to the aggregator.
Okay. Event-driven or timeline? I mean, every night you do it, or event whenever the scanner does it?
Yeah, parser is like once in a day, I guess. Yeah.
Cool. And we're happy to chat afterwards. I think we're at time, but we're super happy to stay and chat with anyone afterwards. Just come up and speak to us.
Thank you.
Thank you.